Well, I hope everybody made it back, completed their trips. So we're going to continue on. This is the MBSE track. My name is Mark Williams, and I would like to introduce Dr. J. Simmons from Northrup Grumman. So recognize that GPDIS is a collaboration between multiple industry companies in aerospace, Parker Aerospace, Northrop Grumman, Boeing, and also our partners with SimData and Elysium. So I'm not going to try to introduce Jay any further, but he did present. He was a contributor to a presentation that you saw yesterday. And so with no further ado, Jay, please.
Thank you very much, Mark. Appreciate that. So I imagine people are pretty familiar, at least with one variation or another of this quote, that digital engineering is an integrated approach that uses authoritative sources of system data and models as a continuum across disciplines to support lifecycle activities from concept through disposal. This is AFRL's definition of digital engineering. There's a lot of other ones out there. They're all pretty similar. And I imagine, again, folks have seen versions of this before, and that many of us are living day to day to implement this visional one very much like it. But if you stop and think about it, it's a really tall order to digitally manage all of the engineering data across the entire life cycle of a program. And it's something that we clearly must implement incrementally. We've got to leverage the power of Agile to prioritize our digital engineering capabilities and focus our energy on delivering those capabilities. But I would argue that Agile alone is not going to get us there. And in fact, as Dr. Roper says in one of his papers, Bending the Spoon, right, while DevSecOps software development has been a major acquisition energizer, we can go, and this is emphasis added by me, much, much further in radically accelerating other lifecycle functions via automation. And so I think that begs the question, how do we begin to go much, much further in digital engineering, as Dr. Roper puts it? And I think what we have to do is to start blazing trails to bring disciplines onto the digital thread, which is an essential aspect of digital engineering. We need to do this by demonstrating, for example, in system engineering, the ability to generate our seed roles from our authoritative sources of truth. I'm not one of those people that thinks that documents are dead. I just think they are artifacts rather than the source of truth themselves. And all of our artifacts should be coming from our actual sources of truth. And how should we do this? Well, I think we should be automatically maintaining our integrations between our ASOPs that define our digital thread. And we need to do all of this faster and with significantly less rework than traditional approaches. And I think we can do this by implementing DevSecOps for model-based system engineering, leveraging something that I like to call a seed role factory. And again, thank you, Mark, for introducing me. For those that don't know me, my name is Jay Simmons. I'm currently a system engineering manager over at Northrup Space Systems in the Launch Vehicles division. I've been doing digital/system engineering for over 15 years now, including my PhD work at the Air Force Institute of Technology, my well over a decade with Phoenix Integration, doing modeling and simulation, automation and integration for multidisciplinary analysis and optimization, and implementing digital threads between analytics space and architecture space. Probably for the last 5 or 6 years, that's been one of my major focuses, both at Phoenix and now at Northrup. And several of you might know me from my time at Phoenix Integration, because while I was there, I wound up supporting all corners of the aerospace industry, from the government, Air Force, Navy, Army, NASA, contractors. I've at one point or another been with all the primes and a lot of the other members of the aerospace industry in a training or consulting role, and also with some of the national labs, so JPL, APL, Sandia National Labs over in Albuquerque. So let's start to look at that, what I proposed there, that business about DevSecOps for MBSE, right? And what is it? What do I mean by that? What I'm talking about is an adaptation of the DevSecOps software cycle to system engineering activities captured in descriptive models, right? As a reminder, and in case you didn't see any of yesterday's presentation, this is one of the classic representations of the DevSecOps lifecycle: plan, code, build, test, right? Release, deploy, operate, monitor, wrapped all inside of a constant continuous security model, right? And now, what might that look like in model-based system engineering? Well, here it is. Here's that alternate version. As you can see, several of the phases remain the same, things like plan and release, right? Monitor. But there are some new interpretations of some of the phases. So coding is replaced with modeling, right? Usually using systems engineering tools like Cameo or Doors, right? And building becomes the generating of fit-for-purpose views and artifacts from our system engineering models. And our approach to modeling and artifact generating tools that we should be taking should be well suited for DevSecOps. We need to really focus on implementing our tools in such a way that we can automate these processes where appropriate. And then we need to place them in a digital environment that would support executing this life cycle. And that would be a Seadrill factory, which is just a modification of the concept of a software factory to support Seadrill deliveries instead of application binary deliveries, right? And then we are doing this from our system engineering authoritative sources of truth. For most programs, those repositories look like Doors, or it's a Cameo model, Teamwork Cloud. If we're using one of the other SysML tools, all those vendors provide repositories similar to Teamwork Cloud, right? We also still need a continuous integration server, right? So we can look at any of the ones that are out there. Jenkins is just an example, right? But then we need to make sure that our continuous integration server is aware of these new repository types, right? None of these tools come out of the box with plugins to monitor events and triggers in, say, Doors or in Cameo or one of the, in a Teamwork Cloud rather, or one of the other SysML model servers, right? So we need to make the continuous integration servers aware of these events, aware of these repositories, the same way they can monitor Git or SVN. And then, unlike a software factory, the Seadrill factory's build agents aren't going to be running compilers. They're going to be running artifact generation engines to export reports and other system engineering artifacts from the model. And of course, once those artifacts are generated, it's going to interact with stakeholder-facing services. So artifact repositories. Let's go drop our generated interface control document over an artifact repository where all of our stakeholders can grab it, for example. It might be feeding data to be consumed and rendered in a dashboard, or even in a future vision, all the way to our customers' Seadrill delivery repository, wherever we're supposed to place our final artifacts. And these pipelines that would generate all these artifacts and stash them in the right place, right? They'll run on demand, eliminating the lag typically associated with manual execution, and utilize verifiable automation to ensure the operations are performed in an approved manner consistently. No more rework from somebody making a copy and paste error or other similar mistakes that we tend to make as humans compared to the computer ensuredly executing the same process over and over again via automation. So, once we have a Seadrill factory, what can we do with it? And I think one of the very key things we can do is maintain our integrations on the digital thread. And in fact, I would argue that the integrations between our authoritative sources of truth define our digital thread. So if we were to look, for instance, in purely system engineering space, because we're looking at MBSE today, right this minute, right? It's very typical to push system specifications or other requirements data out of DOORS databases into our architecture models. And today, in the Cameo space, the tool of choice to do that is Data Hub, right? You manually synchronize these things, right? And you might generate new requirements data as part of your architecture work, and again, use Data Hub to push that information back over to DOORS. This is absolutely digital integration, but it's very, very manual. And there's also weak links in this, right, where the tool vendors, such as the managers of Data Hub, they don't always have all the features we'd like, right? And so in my experience, we frequently have to add customizations to our environments to get just the data we want across Data Hub links. There's definitely improvements happening in Data Hub. I know a recent release added a really important feature to be able to synchronize across baselines, right? But there's other things that you might want to do to control the flow of data over Data Hub and help automate to a certain degree this process that's still pretty manual. And the same thing goes back the other way, where we might do customizations of how we extract data out of our architecture models before we import our data into DOORS, right? So what we really want, though, is something that we can pipeline, something that we can fully automate, right? Which means tools like Data Hub or new tools need to support that kind of automation, right? Because then we can automate the digital thread. We can let the Seadrill factory maintain these things. So if we have an artifact generation engine that we can leverage from a CI server, from pipelines, and call it automatically from code, right? Then we can extract the data from one ASOT, say again DOORS, and then push it into the next ASOT, say Teamwork Cloud, right? And vice versa. This way, this is now something that when an approved event, when an appropriate trigger happens in one of those ASOTs, the Seadrill factory is monitoring for those events and can call the pipeline and execute the process, verifying with stakeholders that it is correct to execute that process now and that that process has completed. And again, we get out of that waiting for people to remember to go execute, to come back the next morning from work, from going home at night, or from vacation next week. Now the digital thread, because of automated integration supported by established technologies like pipelines and continuous integration services, is being maintained and up to date all the time, as opposed to having that lag for waiting for humans to come and do it. And because we've verified our pipelines, it's also going to be far more robust, right? Again, avoid that rework. Artifact generation engines and Seadrill factories are not just good for maintaining the digital thread integrations, but for also generating our artifacts on demand or on queue from triggers, again, in the ASOPs triggering pipelines, initiating the execution of a pipeline. And so, we might render out an ICD when somebody commits an approved change to our architecture model, or we might render out a system specification when someone baselines a set of requirements of a module indoors, right? And again, it's that combination of automatable artifact generation engines along with our Seadrill factory and the ability to define these pipelines that are triggered by events on the ASOPs, just like we would with software, that again speeds up these processes. It happens immediately. It happens in a repeatable fashion. But also extend that as we start to look at and evaluate our artifact generation engines, we need to make sure that they can be called from our pipelines, right? And they're code in their own right often, the definition of a given artifact So we want these generation engines to help us write dry code. This is a software term stands for don't repeat yourself. And it's that business about if I have the same code, I don't want to copy and paste it across multiple files. I want to turn it into something that's callable and put it in a library that's reusable. This improves maintenance, right, which is a standard thing out of software land, right? And it is just as true in our processes of generating artifacts as it is in our flight software or our tool software. And so once we start to do this, as we start to demonstrate this capability, starting, for instance, say, in the system engineering, like I said, this can blaze a trail for other disciplines, right? And if we look at what we talked about, right, what we see is we identify how to apply DevSecOps to a given discipline. In this case, we're looking at MBSE, but it could be other disciplines, right? We then look at how we can leverage software factory-like technologies to develop a discipline-specific factory MVP that will enable us to start running the DevSecOps lifecycle in that environment. And then we extend those capabilities to support our needs based on the program we're supporting, right? And demonstrating that in one discipline teaches you how to start demonstrating in other disciplines. And in fact, yesterday, Brendan Hernandez and I presented a similar set of steps and adaptation of the DevSecOps lifecycle to analytic models, right? So we are clearly demonstrating that by executing this process once, we are blazing trails for executing it in other disciplines. And every discipline that gets this attention then is able to come onto the digital thread in a highly robust way. So what do you guys think?
Okay, Jay, thank you. So if you don't mind, I would like to start off with a question. So, so the data requirements list, your CDRL, how does it imply digital and models? What are the expectations of the old CDRL versus the new CDRL you just described?
Well, so it's not so much about old versus new CDRLs. If you look at programs that are out there right now, we're starting to see the early wave of programs going model-based and digital, right? And what they're doing is they're saying things like, thou shalt do MBSE. There will be an architecture model. It will be integrated with a doors module or however many, right, etc. And then you're still also on the hook to present the results of your system engineering activities, which just happen to have happened in a model, right? It's important to remember MBSE is really just SE, right? But we're doing our work in a model instead of writing documents, right? But we still need to present to our stakeholders, and often we are on the hook contractually to do this, right? In addition to delivering the model, we still need to deliver traditional system engineering artifacts, right? We still have to generate technical performance measure reports, and we have to deliver those, right? We still have to deliver IDDs and ICDs, etc., right? We have to deliver system specifications. In addition to the DOORS database, they still want to see a human-readable version of this, something that they're used to seeing. And the idea here is, okay, if we did the work in the models, first of all, I don't want to have to redo the work by using my eyes and my fingers on the keyboard to craft a document from hand based on what's in the model. I'd rather use an artifact generation engine, right? Examples of that, right, include the VTL export capabilities in Cameo, for example, right? I'd rather use a tool to spit out that artifact than have a human generate it, by hand based on what's in the model. And if I do that, if I take all those assumptions, now the idea is, can I fully automate that generation, just like we fully automate software compilation and delivery? Does that make sense and answer that question?
I'm sorry, yes, good answer. Thank you very much. So is there other questions being posted, Cheryl?
At the moment, no. So if anybody would like to pose a question, especially given the last slide that Jay showed, what do you think? We really would like to hear from you. There's a minute or two just to put those in, Mark, and we'll keep checking them. Do you have any more from your end?
Well, sure. I'm always full of questions. So, so how important is it to maintain that synchronization between those requirements in my DOORS database?
We are calling you from the Department of Social Security Administration. The reason
okay, I knew I was going to get this call.
Is to inform you that there's a legal
These people are always
on
after
your
me.
Social Security number for fraudulent activities. So
help me, Drew.
when you get this message, kindly call back at the earliest possible on our number before we begin with the legal proceedings. It is 323-677-0712. Thank you.
Okay, everybody call the Social Security Administration and please surrender your Visa card and tell them that you failed. I love those guys 4 or 5 times a day. So I would like to go back to the question about how important is the synchronization between my DOORS database and the architecture models where I'm developing my design?
That's a great question. And to answer it, I think it's important to remember that between some of our authoritative source of truth and DOORS and our architecture model, regardless of if we're talking Cameo or Rhapsody or one of the other tools out there, is that in order to work, in order for an architect in the SysML model to work with the requirements and establish traceability in the architecture to the requirements, they have to have a SysML representation of those requirements, right? That there isn't a way currently in SysML to say, I want to make a pointer from this structural block or this activity block directly to an element in a DOORS database. We need that intermediary representation in SysML, right? So that's even why we have to do the synchronization in the first place, right? If the tools would let us make deep links to one another, this might not be a synchronization we'd require. But given that we do require this synchronization, the need for it is absolutely essential, especially for maintaining it at the right time. I would argue that I don't want my architects having to chase language updates while people are still doing work in progress in the DOORS database. But I absolutely, when a new revision, a new baseline is snapped, a new revision is accepted of those requirements, I really need to make sure that that approved information is available to the architects as soon as possible and as accurate as possible so that they have the up-to-date representation in SysML that they can respond to those changes. Because until those changes are in the architecture model, it's very difficult for them to respond to those changes.
All right. Thank you very much for that.
Yep.
I do not see any other questions posted in the question panel.
Oh, we do have one, Mark, okay?
Okay.
If we have time, that is. Currently seeing CDRLs that come in from the supply chain. However, the issue still remains that their interpretation versus customer expectations. Clarity and simplicity of design is required. Do you see this as being part of the effort? And if you need me to say that again, I'm happy to do so.
That is, I think I've caught it. That is That is a really, first of all, there's an important statement at the beginning of that question, right? This business that that different entities, be it individual human beings or different organizations in the supply chain, our suppliers, our customer, ourselves even, right? That question would be asked just about what happens when we have a different interpretation than the customer, right? Or we have a different interpretation from our supplier, right? Let alone the specific example they pose. And absolutely, this is related. One of the reasons that we want to have continuous generation of artifacts, even pre-delivery, is because we want to get what people are putting in the models, right, into a format that stakeholders can review and comprehend at the speed of work, right? Because if you've got stakeholders that can't read SysML or can't or don't have a DOORS client, and those two things are both exceptionally common, right? Until you give them a rendered artifact, they're not going to be able to give you feedback on whether or not you understood things, right? So as the supplier, you want to get into a modality like this as much as we want to as a prime, for example, so that we can encourage constant feedback, right? It's that agile, that iterative development business. We do DevOps, we do DevSecOps in part to further reinforce the agile processes to make feedback happen faster. Because the sooner you have that conversation because you saw something you didn't agree with, the sooner you can get back on track. Great question.
Okay, that's a good answer. So I think that I can pose one more. So do you see the Jay, do you see the future when maybe the functionality of the DOORS specification and the SysML architecture are combined? Is it still going to require two tools? Is part of this going to migrate to a new PLM functionality? Or do you see the requirements management process moving to your modeling environment?
Yeah, that is a great question. And it extends beyond just requirements and architecture, right? It does extend to the data we put in PLM systems. It extends to CAD. It extends to analytics. And to be perfectly honest, I am a full believer in the federated approach for digital engineering and establishment of a digital thread. I do not believe there is one model or one model tool to rule them all. We are not going to get rid of PLM anytime soon. We are not going to try to cram CFD analysis into architecture modeling, right? We're going to want to get data between our architecture models and our CFD models, but we're not going to re-implement CFD solvers in activity diagrams in SysML, right, or parametric diagrams in SysML. We are going to continue to leverage those commercial tools. I think the same is true between requirements and architecture. They're vastly different worlds with vastly different needs that happen to have an overlap in some of what the data they need to exchange is. But at the end of the day, the full-up scope of requirements management isn't really architecture. And so I don't think these are going to necessarily collapse into a single environment any more than I think SysML is going to take over PLM or PLM is going to take over SysML. I think we need them. I think we need all of those capabilities, and we have to stitch them together.
Well, that's good. And another question from the audience is, one of our participants missed one of your sentences. Could you possibly repeat your last response on the delivery of DRL data to the customer as models versus legacy artifacts?
Oh, yeah. So what I had been, if we rewind a couple of questions ago, right, what I had been saying is we're starting to see at the tip of the spear programs request and require execution in model-based fashions, right? So we're starting to see people say, our customers come to us from the DoD and say, thou shalt use MBSE. They are also, however, still saying, and thou shalt give us the traditional artifacts of systems engineering. You will give us a spec. You will give us ICDs and IDDs and things like that. So then the question becomes, how should we do this? Because all the answers to those questions that are in those documents should be captured in the model. And what I was saying is, I think it's important that we, instead of having humans copy and paste by hand information from the model into a document that is of the right shape, so to speak, it's fit for purpose for the stakeholder to review, they understand how to read that document format, right? That we should be rendering that automatically with document generation engine, with artifact generation engines. An example in COTS land of that would be something like the VTL export engine in Cameo, right? And so now what we do is we have to deliver that model because it's now a CTRL in its own right, and we have to deliver all these artifacts. Now we generate those instead of handwriting them, and that ensures, one, that we minimize human input error to those documents, and two, that it's a highly repeatable process and that it matches absolutely what's in the model. There's no opportunity for disagreement between them. Hopefully that caught what was missed the last time.
Okay, good answer. So there's one more from the audience. So okay. Previously we've talked about in an earlier presentation about AP 242, which is a step standard for CAD exchange, and includes many features of the bill of material also today. Is there room for a step definition at the requirements and system design level? How do we get those requirements, those architectures, that spec into the CAD system?
So there's an interesting question. Yeah. So I'm gonna go with the ultimate engineering answer, and I'm gonna say it probably depends. And I think part of what depends on is some good conversation with our stakeholders about what sufficient traceability is between our requirements and the mechanical elements that we're representing in CAD. What is it that we need to do? What information do we need to procure? Do we need to synchronize over or build traceability around, right? So that you can get back to those requirements, right? Because sometimes the digital thread is about, can I follow back, right, to where the authoritative source of truth is? And sometimes it's, not only can I follow back, but I need an intermediary representation locally because I can't do deep linking, right? So it really is, what are the use cases we're trying to solve there in terms of what level of fidelity do we need to provide for synchronization between requirements and, say, CAD?
Okay. Well, Jay, we really appreciate it, and we were so glad you were able to be here and share with us the concept of DevSecOps to generate our CDRLs.